We're in geometry. Today is Wednesday, January 23rd. Make sure that you have the date on your paper. Make sure you have the name on your paper. Today we're talking about special right triangles. This is one of those really big topics. In geometry, there are probably 4 really big topics that you need to know for the rest of your mathematical career. And there's not very many of them. This is one of them. This will be on your SAT. This will be in Algebra 2. This will be in pre-calculus. This will be in calculus. You will need these for the rest of your mathematical career. This is a big day. All right, so special right triangle. When I say that, what do I mean? These are two triangles that are used a lot. They won the popularity contest. Who are the most popular triangles? They are these 2 triangles. They would be in the yearbook on a special page because they're so popular. Why are they so popular? The answer is they come from these really basic shapes. So if I start with a square, and we can see I clearly have a blue square even though it's not color-coded on your notes. I start with a blue square and then I cut it in half across the diagonal. If I cut it in half across the diagonal, I get this 45, 45, 90 triangle. This is one of the 2 triangles you are responsible for memorizing. Let's analyze where these ratios are going to come from. Eventually I'm going to have a ratio here, here, and here, and those are the numbers you will need to memorize. So let's assume that this leg is x. Let's just make that assumption.
Me too. Mine broke. Same.
My pencil is random.
Do we really need 3 pins?
No,
Let's assume that that length is x. Because we started with a square, this length down here should also be what? Quiet raised hand. Participation card. Or points if you're Aurelio. Ellery. It should also be x. It should also be x because this was a square. This length is equal to this length. Go ahead and put a little tick mark and a tick mark. Those 2 lengths are the same. They are congruent. Thank you, Ellery. Oh, that's not what I want to show.
show my grades.
Wrong class.
My privacy isn't that right?
Ellery. We can cut that part out. All right. If that length is x, that length is x. Let's call this length, for now, we'll call it y. We're going to solve for this y.
Wait, could you scoot up just a tad?
Scoot up like that.
Please. Thank you. Down, same thing. Okay, that's good. Thank you. Go back now.
Okay. We're going to solve for this y. We want to figure out what it is in terms of x. I could have called this box. I'm going to call it y. So, use the Pythagorean theorem. Solve for this variable. Who can help me set up Pythagorean theorem by a quiet raised hand? If you still have your card. Anna. Thank you. Anna, go ahead and turn in your card. X squared plus x squared does equal y squared. So from there, we need to figure out what this unknown thing is squared. So what is x squared plus x squared? Can anyone simplify that for me? Colby? It is 2x squared. How many of these x squareds do I have? I have 2 of them. 2x squared is equal to y squared. I haven't changed the right-hand side yet. What we're going to try to do is we're going to try to solve for y. So y is almost by itself right now. It has this pesky square. How do I undo that square? What am I going to do to both sides? Caroline. Square root both sides. Write it down in your notes. We're square rooting both sides. And now I have y by itself. Because the square root and square cancel each other out. And I now just have the square root of 2x squared. I can simplify this even further. Whenever I have something inside the square root, I can separate it into 2 different square roots. So here I go. I'm going to simplify this as the square root of 2 times the square root of x squared. You can just separate them into their own square roots. That's still equal to y. I haven't changed the right-hand side. Yes?
Why don't the square root and x squared?
They are about to right now. Yeah, you're seeing the next step. All right. And I guess it has been spoiled, but it is a great insight. This square and this square root will cancel each other out, but this square root of 2 does not cancel out. It's just left with square root of 2. So this square root, this square cancel each other out. Cross those out in your notes. And I'm left with y. Let's write this nice and big. Y is equal to, if I have x, I'm going to put that out front. I'm going to just put it in front of the square root of 2. So I'm going to have x times the square root of 2. And that brings us to our formula that we are going to memorize. This is something you're going to memorize for the rest of your mathematical career. You're going to think about it when you go to bed. You're going to think about it as soon as you're on the bus. It's x. It's x. And x, square root of 2. This is star. This is something that you are going to rewrite in your summary. You're going to be using this over and over on the homework. For your summary, yes. Notice that it is a 45, 45, 90 triangle because if we started with a square, this was a 90-degree angle that I bisected. I cut it in half. 90 divided by 2 is 45. That's why I say 45, 45, 90. That means if I chose this leg to be 1, this leg would also be 1. This leg, or this hypotenuse, would be 1 times the square root of 2, or just square root of 2. We'll be seeing an example on the back. Before we do that, let's tackle the origin of the 30, 60, 90 triangle. This triangle right here is the other triangle you're going to have to memorize. We're going to dissect where these ratios come from. So if I started with a perfect triangle that had 60 degrees for each of these lengths, this is called an equilateral triangle. If these were each 60 degrees, that means that this angle was bisected, and therefore it is a 30-degree angle, which matches with our picture down there. Great. So I'm going to call this length right here x. That means this whole length is the same as this whole length. Quiet raised hand. Who can figure out what this whole length is if this half of a length was x? Quiet raised hand if you still have your card. India?
2x.
It is indeed 2x.
No way.
Let's analyze why that's the case. This whole length is the same as this whole length. That's the definition of an equilateral triangle. This length and this length are the same. We took half of that length, so the whole length here should have been x plus another x, which means this length over here is 2x. Nod our heads if we're following. All right, good. The hard part is figuring out what this unknown red dashed line is. I'm going to call that thing y. We're going to solve for that, and then we're going to write it down for our formula. Here we go. Who can set up Pythagorean theorem for us? And did I give India? I did not. Your XP. Who can help us set up Pythagorean theorem? Beverly.
X squared plus y squared equals 2x squared.
There it is. Thank you, Beverly. Go ahead and write it down. And be careful here because it's 2x. All of this 2x squared, not just the x squared. So we do need parentheses around here. Thank you, Beverly. All right, this is going to be a challenge here. It'll be a little bit of a tricky answer here. Does anyone know what 2x to the power of 2 is? Review from Algebra 1. And let me do some notes on the side. I know that people know it, but someone that has their card, does anyone know it like that? So if I had 3y and I was trying to square that, this is the same thing as 3 squared times y squared. This square kind of distributes into each of these terms. And therefore, when I do this, I get 9y squared. Bless you. So 3y squared is 9y squared. Does that help anyone to solve what 2x squared is?
Okay.
2x squared. Anyone that still has their card. We need to get everyone participating today. Eventually, we'll be having questions. Leo, go for it. It is 2 squared times x squared. Leo, simplify 2 squared for us. 2 times 2 is 4, yes. So I'm going to back up here, and I'm just going to write 4 here. I'm going to skip a step. Thank you, Leo. 4x squared. And that's still equal to, on the left side, nothing has changed, y squared plus x squared. All right, we're trying to solve for y squared. We're trying to get this thing by itself. Well, I guess we're trying to solve for y. But for now, we need to move this x squared over. So what am I going to do? What's my next step? I'm solving for y. What is my next step to isolate y? Someone that still has their card. I know there are people in here that know this. They can talk to their neighbors to help us out if they want. What is the next step here? I'm trying to solve for y. Quiet raised hand. Did you already turn in your card, Luria? No? Okay, go for it, Luria. Oh, this is pronounced x squared, not 2x. So, say it one more time.
Subtract x squared.
Yeah, so subtract the x squared from the 4x squared. So you're subtracting from both sides. That canceled out the x squared here. And I'm left with, is there another quiet raised hand that can simplify this one for us? Thank you, Larry. You can turn in your card. Can someone help me simplify 4x squared minus x squared? I had 4 of these, but then I subtracted 1. How many do I have left? Quiet raised hand. Emily. Say again? Not quite. So 4 minus 1. Say again. Yes, 3x squared is equal to y squared. Perfect. And we're almost done. We are almost done. I now need to get y by itself. I need to get y by itself. What is my final step? Well, it's the final step that I have to do to both sides, but then I'll have to do some simplifying. What is the next step to get y by itself? Chewy. Square root? Yeah. He's making the gesture with his hand. He understands the symbol. Square root both sides. And Chewy, what do I have on the right-hand side?
You shall have 3x.
3x like that?
That's right.
Careful.
Oh, sorry. 3 squared.
Very careful on this stuff.
So you have to separate this into 2 different parts. I'm still going to give you your XP because I was just trying to challenge you there. So there's going to be 2 different parts. Just like we did up here, where we separated this into 2 different square roots, we're going to separate this one into 2 different square roots as well. So Chewy, you want to go for it again?
Yeah. So it's going to be x, right?
X because...
X square root 3.
Oh, you're already ahead of us. So I'm going to write it out step by step. But it's going to be the square root of 3 times the square root of x squared. And you already simplified that for us. And I'm going to talk about that for a sec. But I'm going to give you double XP because that was a harder question too. Yes, it's going to be square root of 3 times square root of x squared. I just separate those 2. And Chewy already saw that this x squared is going to turn into just a normal x because the square root and square cancel each other out. And I still have the square root of 3, which I'm now going to throw on the right-hand side. Square root of 3. And there it is. This length is x squared root of 3. So these are the lengths that you have to memorize. This is the most important step that we can write now. If this length is x, this hypotenuse is twice that short leg. And to get to the long leg, you have to take the short leg and then multiply that short leg by the square root of 3. Burn that into your memory. Long leg, multiplied by square root of 3. Short leg is the original x. Hypotenuse is double. And it makes sense too because 2 times x is bigger than square root of 3 times x. Square root of 3 is only 1.7. Square root of 3 is smaller than 2. 2 goes with the hypotenuse. The hypotenuse is always the longest segment of a triangle, of a right triangle. All right, we're on to the back. We're doing an example. All right. Who can use our formulas above to do example 1 for us? We're starting out nice and easy. If this length was x, then how do I get to this length? What did I do to get from here to here? I had to multiply by something. Quiet raised hand. What did we have to do?
It's the same thing we did in the last two.
It's a little bit different now. We're applying the formula that we have.
What's the formula?
It's this diagram right here. If this was x, to get here, I multiplied by square root of 2. To get from here to here, I multiply by square root of 2.
Can you like write it in a line form?
In a line form?
Like where it's like a cross? Or can you-
It's not really a formula, it's a diagram.
Okay, well,
Everyone can add this to the front side of your diagram too, and this will help us out. To get from here to here, we had to multiply by the square root of 2 times square root of 2. Or if you just prefer, you can do a little dot times the square root of 2 to get from here to here. To go backwards, to go from here to here, we had to divide by square root of 2. So what direction are we going for our example? We're going from here to here, so we're multiplying by square root of 2. So I have 5, but to get from here to here, I have to multiply by square root of 2. So what is x? Is there a quiet raised hand that understands how to do 5 times square root of 2? Quiet raised hand. And since we're burning on time so much, I'm going to open this up to people that have already participated. This is our harder lesson. Multiply these two together. Just squish them together. Anna. 5 squared like this? Not quite. I can still give you XP for trying though. Ellery? 5 square root of 2 like this? That's correct. All you had to do was multiply 5 times the square root of 2, and it's 5 square root of 2. Box it. Just to review, in order to move from a leg of a 45, 45, 90 to the hypotenuse, you multiply by square root of 2. To go backwards, you divide by square root of 2. Let's go ahead and annotate this diagram a little bit as well, with the same markings. To go from here to here, what operation do we do? Do we multiply or divide by something? And again, it's opened up to everyone because we need to get through this lesson now. Beverly, multiply by what? No, not by any square root. To get from x to 2x, I had to multiply by just 2. Yeah. I'll give you the points for trying. Multiply by 2 to get from here to here. In order to get from x to x root 3, though, I needed to multiply by what? Quiet raised hand. Who knows this? India. Yes, exactly. I needed to multiply by square root of 3. Thank you, India. That means if I'm going the opposite direction, if I was going this direction to get from 2x to x, I need to divide by 2. That means if I'm going from x root 3 to x, I need to divide by square root of 3. So going forward, backwards, we know that we're multiplying or dividing by 2, multiplying or dividing by square root of 3. Have this written down in your notes. It makes it look messy, but it will help us in the long run, I promise. We multiply by square root of 2, divide by square root of 2. Multiply by square root of 3, divide by square root of 3. I lost you? In order to get from the short leg x...
No, I get it.
You're just joking around? Or you suddenly came to an epiphany? Let's go to example 2. I now have 8 and I need to get to x. What operation do I do to go from the hypotenuse to the short leg? What is the operation? And we're going to start shouting these out. What is the operation to get from 8 to x? Divide by 2. And again, that's just matching with our diagram here. To get from this hypotenuse to this short leg, I divide by 2. So, 8 divided by 2, shout it out. 4. It's that easy. Done. That's it.
Oh, yeah.
X equals 4. All we had to do was divide by 2.
I'm gonna guess.
These are what I would consider to be easy problems. We're about to do some hard problems now.
Why do you give us hard problems?
It's because hard problems are in the homework. I need to prepare you for the homework.
And then what is the homework preparing us for?
Life. Your mathematical career is based off of this hard math.
Right. Is what help you do taxes?
Sure. Logic always helps with taxes. All right, so now I started with the hypotenuse and I'm trying to get to the leg. I'm trying to go from 6 to x. What operation am I doing to get from 6 to x, Martine?
Really, Martine?
Divide by square root of 2. Good job, Martine. Turn in your card.
Wow, hooray for Martine.
That's HP. I'm going to divide by square root of 2. So the answer is almost 6 divided by square root of 2. There's a problem with this. The problem is we have a rational in the denominator. We have a square root in the denominator. This is not allowed. Go ahead and write that. This is not okay.
Wait, how did you get that on that one and not the other?
Because I divide by square root of 2 instead of multiplying. Multiplying by square root of 2 leaves a square root of 2 on the top. But if I have a square root of 2 on the bottom, that's not okay.
You didn't multiply with that. You didn't, but like the literally example 2, you divided.
I divide by 2, but not by square root of 2.
But when do you use square root 2, not regular 2?
So this was a 30, 60, 90. So 30, 60, 90 says
like different triangle.
there's 2 different triangles, yes. Yeah, good question.
That's news to me.
6 divided by square root of 2 is not okay. In order to rationalize the denominator, I'm just going to give it to us, we need to multiply by square root of 2 over square root of 2. I'm still multiplying by 1 here. This will rationalize the denominator to make sure the denominator is not square root of 2. Square root of 2 times square root of 2. Does anyone know how to simplify this one for us? Square root of 2 times square root of 2 is, it's not 1, it's square root of 2 squared. Because there's 2 of them.
How'd you get there?
There's 2 of these. When I multiply 2 things together, you square them. I can even write this in a different color. Oops, went back too far.
How'd you do it?
There's 2 of these. 1, 2.
Yeah, where did you get the green one?
I just decided to multiply by square root of 2 by square root of 2. So in order to rationalize the denominator, take this guy and do the top and bottom, multiply by that. Multiply the top and bottom by whatever the denominator is. Now you get square root of 2, come on now, square root of 2 in the denominator, squared, and the top is just 6 square root of 2. So far, so good. We square the bottom. The bottom is going to now cancel out. Square root and square cancel out, and I'm just left with 2 on the bottom and 6 square root of 2 on the top.
And you
We're-
can have a square root on top.
Say again, louder.
You can have a square root on top, but not on the bottom.
Exactly. You're allowed to have a square root on the top, but never the bottom.
How'd you do this?
We're almost done because 6 can be divided by 2. What is 6 divided by 2? Shout it out. 3. So this fraction right here reduces to 3. So my final answer is 3 square root of 2 over 1, which is the same thing as just 3 square root of 2. And that is our final answer. That is what I would consider to be a hard problem. You have it in your notes to refer back to for the homework. Let's try another one where we have a radical in the denominator. We have a square root on the bottom. Radical is another way to say square root. So let's try another one where we have a square root on the bottom. All right. This one is the hardest type of problem I will ever ask you.
Why would you ask me? Why would you put me in hard situations?
This one I need to move from here to here and then from there to there. I'm going from the long leg to the short leg, from the short leg to the hypotenuse. Those are the operations.
So we're going to hit them with the multiply?
Quiet raised hand. How do I move from the long leg of a 30, 60, 90 to the short leg of the 30, 60, 90? Jaden.
9 try?
Yes.
You do 9.
Yep. Then what's the operation? Look at your diagram to get from the divide by.
X. Correct?
Nope. Divide by. It's this operation right here.
Power 3 or whatever. Square root of 3.
There you go. Divide by square root of 3. Good job. You can turn in your card. So let's do this problem. 9 divided by the square root of 3. Well, that is the answer, but I need to simplify this. I need to rationalize the denominator. What am I going to do? Quiet raised hand. What am I going to do to rationalize the denominator? Oscar. Very nice. Yes. Multiply the top and bottom by square root of 3. Thank you, Oscar. If you haven't turned in your card, you can do so right now. All right. This turns into what? Quiet raised hand. Who can do this problem now? Who can simplify the top and the bottom? Just do the yellow step right here. India.
The top's going to be 9 square root of 3, and the bottom's going to be in parentheses square root of 3, and outside of power of 2.
The power of 2. Well said, India.
What's your relative HP looking like?
From there, I know that what's going to happen. What's the next step? You guys are helping me through this one. What simplifies on that bottom? What simplifies, Beverly?
They're gonna they cancel out
What cancels out?
the square root,
The square root and the
the 2.
2. The square root and the square cancel each other out to be left with
9 times 3 to the square root.
9 square root of 3.
Yeah, over 3.
Perfect. And we're on to our final step. Thank you, Beverly. Our final step to simplify this rational. Final step, Ellery.
You divide 9 by 3 on the bottom, which is with 3. So your answer is 3 times the square root of 3.
Perfect. And that is this length right here. Thank you, Ellery. So this length, this short leg, is 3 times the square root of 3. But we're not done yet. We have one final, and this is an easy operation, to get from here to here. To get from the short leg to the hypotenuse. Quiet raised hand. What is the operation of a 30, 60, 90 to go from the short leg to the hypotenuse? Colby. Times by 2. So now I need to do this number times 2. When I multiply by 2, I multiply this number by 2. I don't touch the radical. Who can multiply this by 2 for us? Multiply only the number out front by 2. Go for it, Brian.
6.
There it is. 6 square root of 3. That's our final answer. X is equal to 6 square root of 3. And that is the hardest type of problem I will ever ask you. You have seen it. You have notes for it. For your summary, I'll tell you what to do for your summary. Rewrite this thing. Try to do it from his memory as much as possible. Rewrite the 30, 60, 90. Rewrite the 45, 45, 90. Do it from your memory as much as possible. Refer to your notes as little as possible. Try to do that for your summary. Did you not copy it down for your notes?
I did, but I just don't know if I was looking over.
I want you to try to do it from memory, so I'm not going to show it to you guys. All right, that concludes today's notes. Write your summaries. Once you finish your summaries, you can do your paper homework or your Khan Academy homework.